Professor Urbis White, and we are going to go over trigonometry fundamentals. This is the very first video I'm making about the basic trigonometry class. So let's get started. Okay, we are going to start with a unit circle. There is a center here. The radius is 1. And let's put the coordinate system on it. Here's my x. Here's my y. Alright, and we are going to pick a point on that circle, xy. And if you remember from your algebra, the equation of a circle with radius 1 is going to be x squared plus y squared equals 1. Now, everything starts with that for unit circle trigonometry. And what we're going to do, if you're doing the right angle trigonometry, I will show you the approach. So this one is the unit circle trigonometry approach. What you do, you just take a t, which is the arc. Just think about it as like the angle. And what we are going to do, we are going to specify x as cosine t and y as sine t. Okay? Now, when you do that, remember the unit circle equation. This is equation 1. You can just plug it in. Cosine squared t plus sine squared t equals 1. And that is your very first formula, basic formula of trigonometry. Now, if you do, instead of that, if you are doing the right angle approach, what you're going to have is, you're going to have a right angle. And think about it that you're just actually getting this right angle here. And I have t here, remember? And I have 1 here. And then let's look, and this one was x and y, remember, on the circle. So that means this distance is y, and this distance is x. For right angle, the right triangle trigonometry, we go, okay, well, cosine t, just define it as adjacent side over hypotenuse. So adjacent side is x and hypotenuse is 1. So x equals cosine t. Actually, you come up with the same kind of equality. And sine t, opposite over hypotenuse. And what is the opposite side? It's y over 1. And y equals sine t. And you know that from the Pythagorean theorem, you have x squared plus y squared is 1. And from here you can derive that equation 2 again. Cosine squared t plus sine squared t equals 1. This is very, very handy. So we just define cosine and sine, which is part of trigonometry. Now we are going to go to the angles. So let's think about it. Angles, you can measure them in radians, and you can measure them in degrees. So let's do the degrees first. Just think about it. You have your circle, and we are going to specify the angles as counterclockwise positive. So this is your 0 degree, and the corner of a book kind of deal. That one is defined as 90 degrees. And this whole thing is defined as 180 degrees. And this thing is going to be defined as from here to all the way down. So you have 90, 90, 90, 390. So that is 270 degrees. And then you go all the way around from here all the way around to here. So that's 490 degrees, which is 360 degrees. So I'm going to go ahead and put those angles in there. I'm going to do it in black. So this one is 0 degrees, and this one is 90 degrees. This one is 180 degrees. This one is 270 degrees. And this one is 360 degrees back. And now you can just keep on going around the circle. Now what happens with those other degrees that we're talking about? Let's take this one, the pi over 4. That's in radians, okay? So what is the relationship between the degrees and the radians? I kind of look at my circle. It looks like the easiest way to think about it is that pi radians is 180 degrees. So pi radians is 180 degrees. So I just put that 180 and pi over there. And here, 90 is half of 180. So then pi, half of pi is going to be pi over 2. That is pretty good. Now let's look at this one. I have 3 90 degrees, 270 degrees, right? 3 of 90 degrees. How much was 90 degrees? Pi over 2. 3 pi over 2. Now let's do these intermediate guys. Now let's look at this. This looks like the half of that 90 degrees. How much is half of 90 degrees? That is 45 degrees. All right, that is pretty good. So I did that. So it looks like I have 1, 2, and here's another one, 45 degrees. What do you think that's going to be? So 45 times 3. So that's going to be 135 degrees. It's right here, 3 pi over 4. And then let's look at this one, 5 pi over 4. That's another 45 degrees. What is that going to be? That is going to be how many? 1, 2, 3, 4, 5 of them. 5 pi over 4, or 5 times 45. How much is that? 5 times 25, 225 degrees. All right, and you can actually use this as an exercise and go fill out all these things around the circle. These are your basic ones. So this one is 30 degrees. This one is 60 degrees. All right, very good. So I have 30, 45, 60, 90. And what is that one? This one is 60. So that is going to be, again, this is 45. So that's going to be 30. So 90 plus 30, 120. I know this one is, we did already, 135. And this one is, what is that going to be? 180 minus 30. So that's going to be 150. And so I have 180 here. So how much is this guy? So I know it is 30 degrees. So 180 plus 30, that's 210. And this one I know it's 225. What is this going to be? It's going to be 270 minus 30, which is 240. So you can go and fill these out. Now 270, another 30, that's going to be 300. And then what was this one? 7 pi over 4, which is pretty much 360 minus 45 degrees. How much is that? 315, right? Okay, how much is this? 360, this is 30, so that's going to be 330. What will be this one? 300, 315, 330, 360. So we went ahead and actually wrote this down. But what happens if you have some odd degrees? And this is easy to figure out from geometry. So some kind of odd degree. So let's say I have 33.5 degrees. I want to find out what is that in radians. All you have to do is you have to do a little bit of proportion problem. So I know 33.5 degrees, I don't know is how many radians. So I put a ratio in there. And what do I know? I know 180 degrees is pi radians, right? So what do you need to do? Put 180 degrees is pi radians. Here we are. We have degree, degree, radian, radian, and we have a proportion. Now, what were we used to do with proportions? Crisscross. So you have 33.5 times pi is 180 times x. And x turns out to be 33.5 times pi over 180. So what did I end up doing? I ended up taking the degree, multiply by pi, and divide by 180. Okay, so how much is that? So I'm going to go and use my handy dandy calculator right now. So let me minimize this. And let's go in there. This is a TI-84, and I'm going to use this in my videos so you can actually learn how to use your TI-84 while you're doing this kind of work. Okay. All right, so I have my calculator. Let me move it over here. I will, gosh, I wish I had my glasses. All right, so what did I do here? Let me go back. I did 33.5 times pi over 180. 33.5 times pi, and the pi is right here, divided by 180. And you have 0.585. I go back. 0.585 radians. Does this make sense? All right. Now, what I'm going to do, I'm going to do another problem. This time, instead of going from degrees to radians, I'm going to go from radians to degrees. All right. So what I'm going to do, maybe I'll insert a little bit of a space here. A little more. Okay. And let's put it here. Okay. So let's say I am going to find out 4 radians. How many degrees is that? Okay. Now I know that pi is 180. So pi is 3.14. So this is going to be a little bit more than 180. I kind of have a feeling for that. So let's put our proportion together. So I keep the 180 degrees and pi radians on one side. I do it just on the right, doesn't matter. Now you want 4 radians and you're trying to figure out 180 degrees. Okay? I mean, sorry, you're trying to figure out how many degrees that is. X degrees. All right. So you do the crisscross again. So you have pi times x equals 180 times 4. And x turns out to be 180 times 4 divided by pi. Okay? So what did I end up doing? This, instead of multiplying by pi and divide by 180, I just multiply by, the radian and then divide by pi. So 180 times 4 divided by pi. So let's get that, and let's see how much is that. 180 times 4 . 180 times 4 divided by pi. Where's my pi? Here it is. Well, was that, I just said a little more than 180, so you ended up with 229, about that many degrees. All right? So I showed you on the circle, I showed you the unit circle. Okay, so let's, you know, write down the things and right angle approach. Just summarize it. This is my t, and then this is my x, this is my y, and this is my 1. And this is going to be just a circle. Here's my radius, here's my t. X equals cosine t, y equals sine t. All right? And this one is cosine t, this point, sine t. And your graph is x and y this way. And then for the right angle approach, x equals cosine t, because cosine t is adjacent over hypotenuse, and y equals sine t. Sorry, I did that wrong. Adjacent over hypotenuse. Oops. Adjacent x over 1. So let's put that in there. And then opposite over hypotenuse is sine t. Same approach. And then from both of them we got x squared plus y squared equals 1, or cosine squared t plus sine squared t equals 1. All right. Now, let's do some arc exercises. Now, let's introduce the concept of reference angle. Well, if you go to a trig book, the reference angle is the positive angle that your endpoint makes with the nearest horizontal. So let's look at this situation. What is the reference angle? That's how it's shown, x with the hat. If my angle is 11 pi over 6. Okay, there are like a couple of ways of doing this thing. So you can actually go and say, okay, what the heck is that? And I can go and I can figure out where the 11 pi over 6 is. Okay, one way to think about it, pi over 6 is 30 degrees, and then you take the 30 degree and multiply by 11. That's going to give you 330 degrees, so you're going to be in quadrant 3. Now, how do you do your quadrants? You are doing them counterclockwise. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay? So, you go like this. So, 330 is going to be in quadrant 4, somewhere here. And the way that you show it is from the horizontal, and you go all the way around, beginning point of 1, 0, and your end point of whatever that is turning out to be. Okay? We are going to actually go and find those values in a minute. But you are in quadrant 4. If somebody says, what is the reference angle? Then you have to say, okay, well, my reference angle is the positive angle that it makes with the horizontal. That's going to be that. Now, how much is that going to be? I know that it is, this is 360 degrees, or 2 pi. And this one is simply 11 pi over 6. So you can go, or why? It's going to be 2 pi minus 11 pi over 6. And what do? Just put in the same denominator. So you have 12 pi over 6 minus 11 pi over 6, which is pi over 6. So my reference angle is simply pi over 6. Instead of thinking about 11 pi over 6, I can just say it is just pi over 6. This is kind of really nice. Okay, well, let's do a couple of those exercises. So if I have, this is one way of doing it. I have an angle of 5 pi over 3. Where is it? And then what is its reference angle? Okay, so let's go and let's find that out. Here's another way of doing it. Instead of thinking in terms of degrees, 5 pi over 3. Let's think about this. This is 0, and when I go around it, I hit 2 pi. Okay, so when I hit here, so this is 3 pi over 2. Okay, so let's think about it. So if I have 5 pi over 3, which is the same as 10 pi over 6, all I did is just multiply top and bottom by 2. And 2 pi is then going to be 12 pi over 6, right? So I can multiply top and bottom by 6, and to kind of match that, what is that going to be? Then I can actually go multiply top and bottom by 3, so that's 9 pi over 6. Oh look, if this is my 12 pi over 6 and this is 9 pi over 6, that means I am going to be at quadrant 4 when I want 10 pi over 6. And what's my reference angle then? Then my reference angle is going to be 12 pi over 6 minus 9 pi over 6, which is 3 pi over 6, which is pi over 2. I made a mistake. Oh, pi over 3, sorry. What did I do? 12 pi over 6. Oh, that's true. Okay, sorry. I just had to subtract that 10 pi over 6, not the 9 pi over 6. Let me take that out. All right. So this angle is 10 pi over 6. Oops. This is 10 pi over 6. And this one is 12 pi over 6, so I need to take that 10 pi over 6 away. So it's 2 pi over 6, so which is pi over 3. Very good. So this reference angle is pi over 3. Okay, very good. Let's do something a little bit harder. Maybe I will do 17 pi over 6 with the same kind of approach. Where is it and what is its reference angle? So let's look at it. All right. Now, I know that when I go around one time, it's going to be 2 pi, which is the same as I just told you that 12 pi over 6. 12 divided by 6 is 2. Okay? So I go around one time, and then let's see what happens. Now, 17 pi over 6, and then 12 pi over 6 is one around. So let's take that one around out. So what I'm going to do is 17 pi over 6, and take away one turn around, because it's more than one around. So that is going to give me 5 pi over 6. Okay, so what I did, I went around one time. I reached the 12 pi over 6. Now I'm going to go another 5 pi over 6 away. So let's look at that. Where is that going to be? So I know that this is pi over 2, right? Which is the same as, let's multiply top and bottom, 3 pi over 6. So I'm going to have to go around one time, past this thing, 3 pi over 6. And what am I going to have? I'm going to have a little more and end up right here. Does that make sense? Okay, so I am in quadrant, this is 1. I'm in quadrant 2. And so, you know, that tells me that how do I find the reference angle? So you can do it a couple of ways. And I know that from here to here, that is 5 pi over 6, right? And to find this thing, so all I have to do is just take away pi minus 5 pi over 6. And that's going to give me pi over 6. So my reference angle is pi over 6. Why are reference angles important? They're important because you want to go and calculate sine cosine values based on reference angle to make easy for yourself. So to get to that point, what I'm going to do now, I'm going to look at the signs of sine and cosine, okay? So, and to do that, I need to kind of draw a couple of things. So I know that the sine t is like y. So what is going to happen, the y is sine t. Y is positive up and negative down. And how about the cosine? Cosine t, that's just like x. That means it's positive where x is positive and negative where x is negative. Okay, so that's good to know. And also, I just have a couple of values that I can calculate the sine and cosine. I know that sine works like y and cosine works like x. And so, for example, this point, that point is 0, 1, right? So I know that t is 0 there. So that means that is my cosine and sine. Remember, so 0, 1 is going to go, that's going to be cosine t sine t. So that means t is 0 because I'm right here, there's no angle. So that means cosine of 0, I did this all wrong, 0, 1. This is actually, I'm having a brain issue this morning. Let's take this out. This is 1, 0. Okay, so cosine of 0, let's fix that. Cosine of 0 is 1. Sine of 0 is 0. So let's look at this point. That point is 0, 1. So that is going to be cosine of, and what is your angle at that point? That angle is 90 degrees. So cosine of pi over 2 is 0. Sine of pi over 2 is 1. Okay, how about this point? That is pi, remember? So that is negative 1, 0. So cosine of pi, that's going to be negative 1. Sine of pi, that's 0 as well. Let's do this one. That is going to be 0, negative 1. So that means cosine of 3 pi over 2 is 0. Sine of 3 pi over 2 is negative 1. So you can actually go do this. But what happens in these intermediate angles? So actually the derivations are in most books. You can do, I will do a 45 one, and then you can figure out how this works. Let's say I'm looking for what is sine and cosine of pi over 4. And I know that the pi over 4 is simply the middle of that pi, that piece in there. So I'm looking for what is cosine t and sine t values are. Okay? So one thing I know that since this is just dividing this thing into two pieces, so this x and y, remember? So it's going to divide it into two pieces as well. So in other words, this is going to be perfectly symmetrical. So this distance and this distance are going to be the same. Cosine t is going to be simply sine t. And remember my hypotenuse square kind of the right angle triangle formula? I know that this is true. Since they are equal, you can just write it like that. That means cosine squared t is 1/2. That means cosine t is rad 1/2, which is rad 2/2. Look what I did. And since I am here in the positive, cosine t and sine t, so t being pi/4, they're going to be equal, and they're going to be rad 2/2. Okay? You can actually derive the pi/3 and pi/6, but what I will do, I will go ahead and make the little table for you, and then I want you to literally memorize this, okay? So, let's do some basic angles, and I'm going to come back to this, but here's 0, pi/6. Remember, these are the major ones that we talked about right here. Pi/6, pi/4, pi/3. Okay, so I'm going to put that. Pi/6, pi/4, pi/3. And this one is pi/2. So I'm looking pretty much in the first quadrant, these angles, 0, pi/6, pi/4, pi/3, and pi/2. And it is easy to remember these guys. So this is your t's, and this is your sine t. And here's your cosine t. Now, remember we just had said before, this is going to be 0, this is going to be 1, and this is going to be rad 2/2. To kind of memorize what the rest of it is, what you do is, my math teacher told me this when I was in middle school, just go 0, 1, 2, 3, and it's always over 2, and you have the rads. Rad of 1 is 1, so rad 2, rad 3. Here we go. It's easy to remember. And the cosine t is going to be the reverse of that. It's going to be 1, rad 3/2, rad 2/2, 1/2, and 0. Okay? Now, at this point, maybe I will just come back and introduce some more trigonometric functions. So let's see if I can do that. And let me see. Let me introduce a couple of them, and then we're going to go and finish that table. There is something, reciprocal function, sine t. The reciprocal of sine t is 1/sine t. And we are going to give a special name to that, cosecant t. Okay? Cosine t, its reciprocal is 1/cosine t. And we're going to give a name to that, secant t. All right? Now I'm going to define another one, tangent t. That's simply sine t over cosine t. And that's the name of that. And the reciprocal of tangent is called cotangent t. And that is simply 1/tangent t, which happens to be cosine t over sine t. Okay, so I introduced a bunch of new ones. So let's go do that. And I will actually put all this in here. So let's make this a little bit bigger. Increase the height so I can fit all of them a little more. Okay, I think that's enough. All right, so let's do the cotangent. Tangent. Let's start with tangent. Okay, the tangent I know is sine over cosine. I just have to remember that. So what I need to do, I need to go and divide the sine by cosine. 0/1 is 0. 1/2 over rad 3/2. 1/2 over rad 3/2. The halves go away, and it's going to give me 1/rad 3, which is rad 3/3. 4 pi over 4 is these two are equal, so it's going to be 1. So this is going to be rad 3 over 2 divided by 1, 2. And then 2's go, so you're going to simply have rad 3. And then this one is 1 divided by 0. That's going to be undefined. Oh, that is pretty good. So for tangent is 0, rad 3 over 3, 1, rad 3. Well, let's do the cotangent, which is the same as cosine over sine. So this time I'm going to take the cosine and divide by sine. 1 divided by 0, that's undefined. And these two are equal, so it's going to be 1. Now I'm going to do the reverse. It's going to be this divided by that, and the other way. Oh, look at that. What happened was the cotangent is like tangent going the other way. Okay? Now, let's see if I can do the same things for cosecant and secant. Cosecant was 1 over sine. One way to remember that, cosecant starts with a C and sine starts with an S. So C and S go together. So cosecant is 1 over sine. So 1 over 0, that's going to be undefined. Okay? And then you have 1 over 1, so that's going to be 1. And 1 over 2, 1 over 1 over 2, that's going to be 2. What is that going to be? Rad 2 over 2, then 2 over rad 2, and now you just kind of rationalize that. What are you going to get? You're going to get 2. And then, oh, sorry, I just got the wrong one. And that's going to be 1 over sine. So 1 over sine is 1 over rad 2 over 2, which is 2 over rad 2. Rationalize that. So what do you get? You're going to get 2 here, so you're going to end up with a rad 2 here. Does that make sense? Okay. How about this one? That's going to be 1 over that, so 1 over rad 3 over 2, which is the same as 2 over rad 3, which is the same as 2 rad 3 over 3 when you rationalize it. Okay? And then the secant is 1 over cosine, and it's going to be the reverse of that going the other way. 1, 2 rad 3 over 3, and then you have rad 2, and then you have 2, and you have undefined. Okay, so I recommend that you just memorize sine and cosine and derive everything else. Well, let's look at the signs of these functions. Just let's put all in one place. I know that the sine and cosecant work together. So sine is like y, so positive here, negative here. I know cosine and secant work together, and it works like x, positive here, negative here. And tangent and cotangent are reciprocal of each other, so they're going to work together in terms of signs of things. So what is that going to be? It's going to be positive because it's going to be this circle divided by that circle, or the other way around. So you're going to have a negative here, positive here, and negative here. So tangent, cotangent, when the signs are the same, it's going to end up positive, and when one of them is negative, it's going to end up negative. So just memorize this table, and you're going to be fine. So what we're going to do a couple of exercises just now to calculate the reference angle, and then kind of look at some values of them. Okay, so let's go for example, something like this. What will be cosine of 5 pi over 3. Okay? Okay, so let's look at that. Cosine of 5 pi over 3. I'll just do it in a quick way. So where is that going to be? Cosine of 5 pi over 3. So pi over 3 is 60 degrees. 5 times 60, that's 300. So it's going to be 300 somewhere here. So I'm in quadrant 4. Okay? So let's find the reference angle. I know that this whole thing around is 2 pi. And then this one is 5 pi over 3. So to find this angle, all I need to do is take your 2 pi and subtract 5 pi over 3 from it. So let's do that so that you have 6 pi over 3 minus 5 pi over 3. That is simply 5 pi over 3. So my reference angle is pi over 3. All right. Now I'm going to go and get that cosine of that reference angle. Now I have that in my head. Cosine of pi over 3. Oh, cosine of pi over 3. Oh, here it is. It's 1/2. Go back. Cosine of pi over 3 is 1/2. Now I need to go back to my original one. So let's go look at how this worked. I know that the cosine is positive here and here. Very good. So that means cosine of pi over 3 and cosine of 5 pi over 3 have the same sign. Cosine of 5 pi over 3. So that still will be 1/2. All right? So let's check that with my calculator. Now, remember I just learned how to convert the radians, degrees, and back to radians. What I'm going to do, I'm going to make sure that I have my calculator set in radians. That is done with mode. Now you go down and you look. If I want it in radian, I have to pick that one, flashing one. If I want it in degree, I have to enter degree, and then so it's set in degree. But in this case, I have it in radian. So what you need to do now, you need to get out of here. Okay? And then I need to enter what I want, cosine of 5 pi over 3. Cosine of 5 pi over 3. And then this better give me 1/2. Very good. All right. You can do some really fancy exercises, and I will do one of the fancy ones. Now that we know all the functions and different angles, how to convert them, and one hard problem might be you just have everything all together and then throw it in there and you check it with your calculator. So let's try that. Let's say I have sine of pi over 2 plus tangent of 2 pi over 3 divided by secant of 5 pi over 3. What is that equal to? So we're going to use all the different concepts all at once. Let me save this so that I don't lose it. So let's start with sine pi over 2. So I make my little thing. Sine of pi over 2. What was that? That was the y thing. Okay, I kind of remember that. That is 1. Okay? Because this one is 0, 1, and it works like y. So let's look at tangent of 2 pi over 3. Okay? How am I going to get that? Now, 2 pi over 3, where is that thing? Pi over 3 is 60 degrees, so it's about 120. So it is going to be in quadrant 2. So I need to work with reference angles. So in other words, I have this as 2 pi over 3. I need to figure out what the reference angle is. So how do I get that? I'm going to have pi minus 2 pi over 3 That's going to be 3 pi over 3 minus 2 pi over 3, which is going to be pi over 3. Okay, my reference angle is pi over 3. Now, I need to go and remember what the heck tangent of pi over 3 was. Okay, tangent of pi over 3, you can either do it from memory or you can look it up, or, tangent of pi over 3, or figure it out. I know tangent of pi over 3 is rad 3. Now I need to go back and see how the tangent to pi over 3 and pi over 3 related. Now for that, I need to kind of memorize where my tangent signs is. It looks like in quadrant 2, my tangent is negative. Alright, so I know that in quadrant 1, my tangent is positive, but here it's negative. So in other words, tangent of pi over 3 is not going to have the same sign as tangent to pi over 3. So that means tangent to pi over 3 is going to have a different sign, which is negative. So you write this down. Tangent of 2 pi over 3 is simply negative radical 3. So let's do the last one, 5 pi over 3 secant. Again, you need to figure out where you are. Pi over 3 is 60 degrees. 5 times 60, 300. So I'm in quadrant 4. So if my thing is, this thing is 5 pi over 3, what will be my reference angle? This angle. So I need to get that angle, so it's going to be 2 pi minus 5 pi over 3. And that is simply 6 pi over 3 minus 5 pi over 3, which is pi over 3. Okay, that's good. So this is pi over 3. Now I need to kind of memorize or figure out secant is 1 over cosine. Secant of pi over 3. Remember what it was? Secant of pi over 3. Pi over 3 is right here. So secant of pi over 3 is simply 2. Alright, now let's find out if the secant works like cosine, and I know that cosine is positive here. So, in other words, secant of pi over 3 and secant of 5 pi over 3 will have the same sign. So that means, I write this down, secant of 5 pi over 3 is also 2. Now put it all together. So I'm going to plug this in. Sine of pi over 2 is 1 plus tangent of 2 pi over 3, that is negative 3. Where am I? Divided by secant of 5 pi over 3, which is 2. Make it pretty. 1 minus rad 3 of divided by 2. Okay, so you can actually find the values of sine and cosine tangent, and it can be really, really very fancy, but you can, you can do them. So the last thing I'm going to look at, just for the fundamentals, are negative identities, and I will just go with the unit circle again. Now, let's look at the cosine. What happens to cosine x versus cosine negative x? So here's my cosine x. Here's my cosine negative x. This is my x. This is my negative x. Now, I know that cosine is positive here. It looks like it's going to give me the same answer. So, what does that mean? Cosine x and cosine of negative x are the same. Those kind of functions, they are called even functions. So cosine is an even function. the value of x or negative x gives you the same answer. So let's look at sine. Sine is works like y, so it's positive here, negative here. Sine of x, and then sine of negative x. The problem is I know sine is positive here and negative here. So in other words, that's going to give me a value that's off by a negative. So in other words, sine x will give me a positive number, and sine of negative x is going to give me a negative number. So what does that mean? Sine x is negative sine negative x. Okay? All right. So those kind of functions, they are called odd functions. Now, remember I also did secant. So since secant is simply the reciprocal of cosine, I can also do this. It's going to be an even function again. Secant of x is going to be secant of negative x. And same thing with the sine. The reciprocal of sine is cosecant. Cosecant of x is negative cosecant of negative x. Okay, now let's look at tangent. I know tangent is like this. All right, so let's look at tangent x and tangent of negative x. What happens? Tangent of x, tangent of negative x, they are off by a negative. So this is a kind of an interesting fact. Tangent is actually a division of an even and an odd function, so it ended up being odd. So in other words, tangent of x is negative tangent. So this is also an odd function. And cotangent, since it's one reciprocal of tangent, cotangent will work the same way. All right. The very last thing that's left is these are called negative identities. Then the next one is periodicity, and it will really help if you memorize these guys. Remember how we did it? And you can look at the values of sine and cosine, and it looks like it's going to go around and repeat, around and repeat every 2 pi. Okay? So sine and cosine, because of that, periodicity of sine is 2 pi. Cosine is 2 pi. So that means cosecant is 2 pi and secant is 2 pi. So all these 4 functions will have a period of 2 pi. Their values will repeat. How do you write that? You write cosine x plus 2 pi is the same as cosine x. Sine of x plus 2 pi, the same as sine x. Well, you can even put that more generally. You can put it cosine. You don't have to add 2 pi. You can add products of 2 pi. So in other words, you can write x plus 2k pi, k being an integer, is going to be cosine x. K is an integer, like -2, -1, 0, 1, 2. And that is also true for sine x plus 2k pi. you can use this to your advantage. But what happens when you make your little table for tangent and cotangent, you're going to see that the values are not going to repeat every 2 pi, but it's going to repeat every pi. So what we say about tangent and cotangent is tangent and cotangent have periods of pi. That is good to know. And what you can write as tangent x plus pi is going to be tangent x. And then cotangent x plus pi is cotangent x. And you can generalize that as well. You can say tangent of x k pi and cotangent of x k pi, where k is an integer. So that is going to help, because if somebody says, okay, well, calculate what is, an example would be, calculate what is sine of 3 pi, you can go, okay, well, that's more than pi, 2 pi, so it's going to be 1 around 2 pi and 1 more. And you can do a quick calculation. Sine of that is still going to be 0. So take out those revolutions, however many times you're going to go around, and then try to make them smaller, and then kind of put that value down. Always draw a little unit circle. So what I'm going to do, I'm going to summarize all that for all of them. So this is a table that you might want to just print out or memorize or derive it yourself. Here it is. Function, and I'll write down the period. I write down the domain, and I write down the range. Okay, so kind of like think about it how you do that. Sine x, that works like y. It has a period of 2 pi. And I can plug in whatever I want to take the sine. It doesn't really bother me. So I can plug in any value. So the domain, that means I can plug in any x values. It's going to be all real numbers. But the range, when you remember your little circle, the most you can have is 1, and the littlest number is -1. So your range is going to be -1 to 1. Now let's look at cosine. How does that work? It also has a period of 2 pi, and I can plug in whatever I want. And again, that works like x, and it goes from -1 to 1. Now let's think about tangent. The tangent, we just talked about this. This has a period of pi. Everything is fine, but remember how it was. At pi over 2, you're dividing by 0. So I can have everything but pi over 2. I cannot have that. And then I can go around the circle, since it has the periodicity of pi, k being any integer. So in other words, I can add 1 pi to it, subtract 1 pi from it, 2 pi to it, 3 pi to it, subtract 2, 3 pi from it, from pi over 2. Those values is going to blow up. You don't want to take tangents of that. How do you know? In your calculator? Your calculator will give you an error. Okay? What will be the range? Remember, you know, even though if I take these things out, I am not limited by these things. The tangent numbers can get really, really small or really, really big. So in other words, the range is going to be the y values. It can be anything, unlike like sine and cosine. So let's do the reciprocal ones of the sine, cosecant. And remember, cosecant works just like sine, so its periodicity will be the same. But the problem is I don't want to divide by 0. Where is sine 0? Okay? So you don't want to have pi or 2 pi or 3 pi. How do you put that? X cannot be k pi where k is simply an integer. Okay? Now, what happens with the cosecant? And you want the cosecant. This is a little bit more advanced. We are going to kind of look at that. But the absolute value cosecant is greater than 1. In other words, you cannot have values between -1 and 1. But 1 and up is fine. You can have very large numbers, very small numbers, but you cannot have anything between 1 and -1. Now, how about secant? Secant will have the same periodicity, so it's going to have 2 pi. But I need to take out the things where cosine is 0. Where is it 0? It cannot be a pi over 2, or I cannot have k pi things. I can add 1 or 2 because that's going to repeat. The 0 will repeat every pi interval. And then again, the same thing for secant. I cannot have values between 1 and -1, so I need to write that as that. So let's put the cotangent. And we talked about cotangent being the same as the periodicity of pi, but I cannot have where the denominator is 0, and that's going to be k pi area. And then, but, I'm not limited, by that, and the cotangent, it's not a problem, and you're going to get all the r's. You're not limited by the values. So we're going to go back, and when we look at the graphs of sine and cosine and cotangent and tangent, we are going to go a little bit deeper and then figure out how we came out with the range. So this will get you started. These are the fundamentals. I really, really recommend you kind of know this table. I recommend that you know the even, odd business related to these functions. You know this table very, very well in the first quadrant and try to derive it. And make sure that you know the concept of reference angle, that you can pretty much calculate whatever you want. And then in terms of the calculator, make sure you set it in the right mode. And then mode degree or radian, I just showed you how to do that. And just push the sine, cotangent, and tangent. Those are already built in. But the secant and cosecant in most calculators are not built in. You just have to take the reciprocal after you calculate sine and cosine. So that's all I have right now, and next we are going to learn how to graph them. Thank you for your attention.